Let's get into some of the properties of triangles and different types of triangles that you might encounter on the test. By the way, in all these videos through the Rebel Academy, I am not giving you anything that you don't need to know for the test. These are all terms that sometimes pop up on the test, and then students are like, I don't know what these are. So I'm only showing you stuff that's going to come up on the test and nothing else, just so you have a heads up in case you're wondering, like, is this really going to be on the test? Yes, probably. There's different versions of the test. Sometimes these terms pop up, sometimes they don't, but I'm preparing you for that in case they do so that you know how to deal with these problems. Okay, so the first triangle we have over here on the left side, this one is called a scalene triangle. Okay. A scalene triangle, put simply, is a triangle that has sides that are all different lengths. None of the sides are the same length. So, for example, if we were to label these with numbers, we could say that this short side right here is 3 inches long, this other side is 7 inches long, and the bottom is 8 inches long. So a scalene triangle is any triangle where all the lengths are different. All right, simple enough. The opposite of that is an equilateral triangle, with equal being the start of that word, which gives you a clue as to what this means. An equilateral triangle is a triangle that has all three sides exactly the same length. So 5 inches, for example, or 5 miles. If it tells you you're working with an equilateral triangle, and they give you one side of that triangle, you knowing what equilateral means will help you jump to that conclusion that all of the sides are the same length as that one that they gave you. Examples of equilateral triangles are the plastic rack you use to play billiards, the triangle that you use to put the balls all in the middle so that you can break the balls for the start of the game. That's an equilateral triangle. So equilateral simply meaning all sides are equal. Okay, then we'll move over to a right triangle. A right triangle is any triangle that has this little box in the corner right here. That tells you that that corner is 90 degrees. And we talked a little bit about degrees in a different video, but we're going to revisit that a lot because when you get into triangles, this is where they're also going to quiz you on your knowledge of degrees. So for now, all you need to know is that a right triangle is any triangle that has a 90-degree angle in it or a perfect L corner. And you can tell it has a perfect L either because the word problem will tell you that you're working with a right triangle. And when you follow those golden rules and you draw it, which is like step 2 or step 3, I can't remember, you will draw it and you'll put that little box in the corner to remind yourself that it's a 90-degree angle. And then last but not least, we have isosceles. Isosceles triangles are triangles that have two sides that are the same length. So we'll say that these are 10 feet tall on each side, but obviously that bottom side is a lot smaller. We'll say that guy is just 4 feet wide or whatever. So if you have two sides that are the same length and one that's different, that's an isosceles triangle. If it helps you to remember the scalene and isosceles, I always thought of it like this. Scalene starts with the letter S, and the S doesn't have any straight lines in it, so it just made me remember, like, okay, none of the sides have anything in common. Like, they're all sort of in a free-for-all, kind of like the letter S is just this big sort of chaotic curve. Whereas an isosceles triangle starts with the letter I, and the letter I has a top and a bottom that are basically the same length, right? And then one line to it that stands alone. So I always remembered this by just remembering, okay, the I triangle, the letter I sort of reflects what an isosceles triangle is like, right? And then a right angle, right triangle, I don't really have any tricks for that one, except that in construction, getting it right, building a house correctly, you need 90-degree angles because if you build them at an angle, your building's going to fall over, right? So in construction, it's right if it's at 90 degrees. Maybe that'll help you remember. And then equal and equilateral is the obvious one, at least in my mind, because all the sides are equal. That's why it's called an equilateral triangle. Now, you may have noticed, and maybe you didn't, but either way, you may have noticed that the right triangle could also be another one of these categories, an isosceles, equilateral, or a scalene. Given that an isosceles has two sides that are equal and one that's different, an equilateral has all sides being equal, and a scalene has no sides being the same length, this right triangle in the middle, the blue one, actually also doubles as one of these other ones. What do you think it is? Is that right triangle in the middle a scalene triangle, an equilateral triangle, or an isosceles triangle? If you guess scalene, you would be correct. You can see just by looking at this triangle, there's a short side, right? There's this side over here, which we'll say is 3. The bottom is obviously bigger than that side is, so we'll call that a 4. And then the diagonal, if you were to kind of measure it, if you wanted to actually physically measure it on your screen, you'll see that the diagonal line of a right triangle is always the longest. And in fact, it would be 5. These are real measurements for a right triangle, which we'll get into that formula later. So right triangles can be scalene triangles. They could actually also be isosceles triangles. I will show you what that looks like. Okay, so I've drawn another triangle for you over here on the right in yellow. So this triangle has a perfect L in it, so it's a right triangle because it's got that 90-degree angle, but it also has two sides that are the same length, just like an isosceles triangle. And it is an isosceles triangle. It is both an isosceles triangle and a right. This other one over here, this was a right scalene triangle, whereas this one over here is also a right triangle, but it is an isosceles, and I'll just abbreviate that. That one's a right isosceles triangle, and that's because this side over here, we'll say that this is 4 feet long. This side down here is also 4 feet long, which is going to make this other line, the diagonal is always the longest. And let's see, that would be 16, 16, 32, like 5 point something is the actual, it's probably like 5.8, something like that. Doesn't matter. We'll go to the formula for how to actually calculate those in a later video. But the point is that a right triangle doubles as something else. It's either a scalene or it's an isosceles triangle. Now, a right triangle cannot be an equilateral triangle because of its 90-degree angle. You can't have a 90-degree angle in an equilateral triangle because then the sides won't be the same length, and I'll show you more about that later. But for now, you've got a couple terms to remember. You have equilateral, scalene, right, and isosceles. Okay, so that does it for this video, just identifying triangles. In the next video, we're going to get into calculating the angles in degrees in the corners of triangles and learn some of the rules for those problems.